Zimmermann is a $2.3 billion conglomerate, essentially an engineering, maintenance, and construction organization based in Philadelphia, Pennsylvania. And they provide retubing and condenser services that require an innovative, equipment-oriented project management activity to accomplish the objectives that are necessary whenever those projects have to be done within a plant. And it's a specialty housed in Norfolk, but capable of working with any customer in the country in either a union or a non-union environment. The confidence that you can have in the condenser division is based on 20 years of past performance.
The main reason someone would want to retube a condenser typically is because they have a lot of plug tubes or other problems that they're having with the environment. But most times it's because they have tubes that are bad and plugged.
The most important part of a condenser retubing to ensure its success is the rolling. That's where you take the tube and actually roll it into the holes in the tube sheet. We actually go through a process to determine what it is we're going to see in the field when we get all those tubes out and we go to put the new ones in and roll them.
So we started doing pull-out tests to know before we start the job exactly how we should roll the tubes to get the optimum torque versus wall reduction to give us what we need to make sure we get an adequate seal.
So each job has its own uniqueness about it, and when you go and look at them to put your bid together and then your work plan together, it really just, you have to look at everything, you know, how it sits, what you need to do to get tubes in, what you need to do to get the equipment in.
The biggest edge really is coming prepared to do the job. We bring what is necessary to get the job to ensure that if we have some issues, we address them to give the customer the job they're looking for in the timely fashion.
We would go in and we have to get off the water box on the end we're going to work on. So we would be starting to take the water box off and the interferences so we can get access to the condenser.
It can be very, very simple where you just unbolt some bolts and rig it off. Sometimes it's very complicated and you need to rely on the services of a specialty rigging contractor to do that.
Removing a bolt that would be every 4 inches to hold it in place, it could weigh up to 20,000 pounds. It may be smaller and only 4,000 or 5,000 pounds, but you will rig it up with chain falls and or crane to remove.
While we're doing that, we would go and find where the expansion joint is. On the condenser, there's an expansion joint on the shell side between the tube sheet and the shell. Could be on both ends, most generally it's on one end, and we lock that down. So we lock it down so it can't move. Then we go in and we start taking plugs out.
We'll have a group that goes in the back, actually entering through a manway, take an internal tube cutter, cut each tube, and then you have a little stub part that has to be moved also in the rear. Now that basically is freeing up for you to do a long pull. Tube removal is basically going to be it's a hydraulic system that's going to use either a walker or the eliminator. We do it on a counterbalance to ensure that we can move efficiently from left to right on a pattern to pull all tubes. You'll move the tube with a hydraulic unit that actually will extract the tube about 6 inches to give you the length for the specialized tooling of the walker in order to grab the tube and pull it out. You come around front, use the hydraulic equipment that's pulling the tube out approximately 200 feet a minute. Whenever we size a job, we have 2 specialized pieces of equipment. We have an eliminator and we have a walker. The walker will move it flat at approximately 200 feet a minute, and then it will move it, crush it, and then we put it through another piece that's called a chopper to get it into 4-inch pieces. So it will be a dense load whenever you have that in boxes for handling purposes back to the scrap yard. The eliminator itself is another design we have where it actually has a blade inside that will not only remove the tube, it will cut it in 4 inches at the tube sheet itself. So you don't have that second step of handling. Threading of the tube sheet is done pneumatically. We have a 7-tooth blade with grooves that's designed to actually remove material from each hole in the tube sheet to ensure a proper seal.
Serration's a way that we use to put them in the tube sheet to help seal between the tube and the tube sheet. You got to remember, we're putting in some cases 75,000 tubes into a tube sheet that might be 1.25 inches thick. And it's a very thin tube sheet, and you've got 75,000 tubes, so you got 150,000 tube ends. So you've got to roll those in and make sure they don't leak.
One of the concerns was the rolling of a hard tube, such as titanium, into either a very soft or a very hard tube sheet. And we found that the smaller the serration and the way that it's designed actually improved tremendously the tube-to-tube sheet joint strength, and also act as a barrier against water getting into the condensator, causing a leak.
After the tubes are out, we go in and we clean the support plates. All the support plate holes have to be cleaned to make sure any rust or anything that might be in the hole is taken out of it, so when we go to push the tubes, we don't have a problem. We go to the tube sheets on both ends and we clean them up and make sure we don't have any scratches or anything that would cause water to follow the scratch and cause a leak. And once that's all taken care of, we go in and we mic holes, normally every 100th hole. And so we have benchmarks as to what we're doing, where we're doing it, and so we know exactly how we're going to roll the tube. Before we put the tubes in, we do check the alignment of support plates. We do put lines down through the condenser at least 4 or 5 locations to make sure that the tube sheet and support plate alignment is what it's supposed to be.
Then the tube process is a very manual process. It's one tube at a time. You have people inside to help guide them through a myriad of support plates that are inside the condenser. Important, but probably one of the easier parts of the whole process.
And then we go in and we roll tubes about in clusters of 10, maybe in 8 places or 10 places on a tube sheet, making sure the tube sheet is good and straight. And we go to the back end and do the same thing with the same tube, so now we know we have the proper alignment between the tube sheets. Rolling of a tube is a device that goes inside the tube. It's a mandrel and pills. And they're in such a shape that the mandrel is on an angle and the pills are on an opposite angle. So when the pill is pushing against the ID of the tube, it pushes the tube out so it's evenly pushed against the wall of the tube sheet. What you're trying to do is seal the tube against the tube sheet material. If you're putting a tube in that your calculation says can only be 28 inches and you're 45, it says the tube is going to fail.
What happens as the steam is coming down from the turbine and hitting the tubes, they start to whirl. And as they whirl, they'll start to either bang against each other and they'll start to cause flat spots and they'll eventually wear through, or they'll start to spin and they'll just break. So we came up with the cradle lock stake.
I worked on this for a lot of years and finally came up with a design that actually locked each tube into position along the device.
It's a metal bar. It's made out of 304 stainless steel. It's custom engineered and it has dimples in it. And we come up with the spacing of the dimples and we come up with the depth dimples. It's unique to the condenser design that we're working on in the tube material and the tube spacing. And it virtually locks the tube bundle into a vibration-free unit. The design and the testing of the stake starts way before the retubing does.
Next step is to hydro test. And when you hydro test, you fill the condenser with water to at least a foot above the tubes. And you typically bring it up slow. So if you find a leak, you roll it as you're working your way up. And then, of course, the water box is put back on before we would do the test also. So the water box would be back on, and then the last test would be to run the circ water, which which is the water through the water boxes to make sure that you don't have any bolts leaking in the water box.
Making sure you make a proper seal, which using a cloth inserted rubber gasket, and then putting the bolts on to ensure you have no leakage.
When we go back to reinstall the water box, basically you put it back on the way you took it off. Protecting our environment is very important. What happens is the cooling water is going through those tubes, the copper tends to leach out and gets back into the cooling water. And that could be the ocean, the river, the bay. There's a huge undertaking to clean up the bay. Part of that process is replacing those copper-based tubes with a stainless or a titanium. It's very important, and it's a big part of the consideration as to what tube material to go into. So they'll get that out of the system, hence clean up the water and improve efficiency all at the same time, so that we continue to be the forefront of the condenser retubing companies out there.
The condenser division, Bob Hahn, Kim Massey in particular, if you could patent folks to run a business, what you get with them is project management, an ability to get from A to Z, a results orientation, and you can see through the products by virtue of their experience.
One of the things that sets us apart is the always looking for some way to improve what it is that we do.
We consider ourselves to be self-sustained. We try to think of anything that is needed to give the customer the job they're looking for with the least amount of interferences. That's our ultimate goal.
We understand the business, we know what it takes, and a person can come to us and basically ask us to tell them what they need, and we can give them everything they need.
I dare say that I am unfamiliar with a customer that has experienced the services offered by our condenser division who would not tell you that they came in and got the job done as prescribed, on time and on budget.